one at a previous session, and then I was just too lazy to do it and said, no, I'm too lazy. But I decided I should go ahead and do it and show you all how to do it. So this one is to find the average and RMS values of the periodic waveform. Even if you don't have to do one of these on the test this year, you do have to know how to do these for signals and systems and other classes, so you might as well practice on it. So we have the function given from 0 to 1, we have one function, and then from 1 to 2, we have another function, and then it's periodic, so it's going to repeat after that. So it repeats, and it has period equal to 2 seconds. And so the average value of any function is the integral of the function over the interval. And so here our interval is 2 seconds, so 1 over 2 seconds. And our integral will break it up into two parts. It'll be the integral from 0 to 1 of 1 minus e to the minus 2t dt, plus the integral from 1 to 2 of e to the minus 2 t minus 1 minus e to the negative 2 dt. And so when we do those integrals, we could just use the calculator to do them, and the calculator should do them fine, but we'll go ahead and do them by hand. So the integral of 1 is t minus integral of e to the minus 2t is e to the minus 2t over negative 2. And evaluate that from 0 to 1. And then plus 1/2. And the integral of e to the minus 2t minus 1 is e to the minus 2t minus 1 over negative 2. Minus e to the negative 2 is just a constant, so its integral is e to the minus 2 times t from 1 to 2. So if I plug in 1 to the first one, I get 1 plus, I'm just going to put that over negative 2, I'll just make that a 1/2. 1 plus 1/2 e to the negative 2, and then plugging in 0, I get 0 plus 1/2 e to the 0, which is 1. And then plus 1/2, and if I plug in 2, I get e to the minus 2 over negative 2 minus 2e to the negative 2 minus, and then if I plug in 1, yeah.
I had joined your meeting so I can see what can't see on the board, and you just.
I need to share?
Yeah. I'm not sure if I can see that. I think it might just be me.
It is just you so far, but thank you. Tell me if you can see it now.
Okay.
Okay, good. All right. Okay, and now when I plug in 1, I get e to the 0, which is 1 over negative 2 minus e to the negative 2. And then there's not really a chance I can do this without a mistake, but I will try. So that's 1 plus 1/2 e to the negative 2 minus 1/2 plus 1/2 negative 1/2 e to the minus 2 minus 2e to the minus 2 plus 1/2 plus e to the minus 2. So if I have the 1/2 on the outside, I can put all of this stuff together on the inside. So I have 1 minus 1/2 plus 1/2 is 1. And then I have minus 1/2 e to the negative 2 plus 1/2 e to the negative 2 minus 2e to the negative 2 plus e to the negative 2 minus e to the negative 2. And I actually end up with the right answer, 1/2 1 minus e to the negative 2, which if you plug that in is 0.432. So that is the average value. Now the root mean square is the square root of 1 over the interval of the integral of the function squared dt. So this would be, so the whole thing would be the square root, and then it'd be 1/2 times the integral from 0 to 1 of 1 minus e to the negative 2t squared dt plus the integral from 1 to 2 of e to the minus 2 t minus 1 minus e to the negative 2 squared dt. So that's all times 1/2, and then all of that to the 1/2 because it's the square root. So then it'd be 1/2, well, all of it, the square root of all of it, 1/2 integral from 0 to 1, and then if I multiply that out, that'd give me 1 minus 2e to the negative 2t plus e to the negative 4t dt plus the integral from 1 to 2 of e to the negative 4t minus 1 minus 2e to the negative 2 e to the negative 2t minus 1 plus e to the negative 4 dt, all that times 1/2, and then take the square root of that. I'm going to go just a little bit more before I say I've had enough of this, and I'll have 1/2 times the integral, it's not, I'll take the integral now, so I'll get t minus 2e to the negative 2t over negative 2 plus e to the negative 4t over negative 4 from 0 to 1 plus e to the negative 4t minus 1 over negative 4. And then this middle part here, that just off to the side, that is 2e to the negative 2t plus 2 minus 2. Because if I distribute this minus 2, I get minus 2t plus 2, and then when you multiply, you add exponents. So then I add in that negative 2, so it gets me 2e to the negative 2t. So this ugly looking term here is really the same as minus 2e to the negative 2t. So when I integrate that, I get minus 2e to the negative 2t over negative 2. And then e to the negative 4 is just a number, so that integrates to e to the negative 4 times t from 1 to 2. All of that is times 1/2. And all of that, we take the square root of it. So then I have 1/2 times, if I plug in 1, I get 1 plus e to the negative 2 plus e to the negative 4 over 4. If I plug in 0, I get 0 plus 1 minus 1/4. And then if I plug in 2, I get e to the negative 4 over negative 4 plus e to the negative 4 plus 2e to the negative 4 minus, and if I plug in 1, I get negative 1/4 plus e to the negative 2 plus e to the negative 4. And that's all to the 1/2. Whoops. And then let's see, what do we have in there? So I've got everything is times 1/2. So I've got a plus 1 and a minus 1. Those cancel out. I've got a plus 1/4. I've got a plus e to the minus 2 and a minus e to the minus 2. I've got a plus e to the negative 4 over 4 and a minus e to the negative 4 over 4. And then I have plus 3e to the negative 4. And all that's times 1/2, and then I take the square root, and let's see how I did. Oh wait, there's an extra 1/4 right here that I didn't see. Or no, I counted that one. No, I didn't count that one. So I had a plus 1/4 and another plus 1/4. That was supposed to be a plus 1/2. So I didn't count that one. It's pretty close. It's supposed to be 0.5136, and I got 0.52. Oh, I see my mistake. It was plus e to the negative 4 plus 2e to the negative 4 minus e to the negative 4. This should have been 2e to the negative 4. And that's even closer. So anyway, it's close. Okay, so somewhere in there, there's some mistake, some small mistake. All right, so any questions on that? Did anybody see the mistake?